Hello friends, welcome to part 2 of the Macintosh SE Reloaded motherboard build. In part 1, I gave a brief history of the Macintosh SE and explained the purpose of the SE Reloaded project. I then proceeded to install small passive components on the board, including resistors, capacitors, and inductors. If you've not seen part 1 yet, I strongly recommend you do that first, because this part 2 video will then make a lot more sense. I put a link for you in the text description below. Kai Robinson is the brilliant reverse engineering wizard who created the SE Reloaded board. And on the Tinker Different forum, Kai explains why the Macintosh SE is 10 to 20% faster than the Macintosh Plus, even though both computers share the same 8 MHz 68,000 microprocessor. Basically, the analog sound generator, timing state machine, timing signal generator, bus management unit, and linear address generator chips on the Macintosh Plus and earlier were all combined into a single IC known as the Bob Bailey unit, or BBU for short, which was named after the Apple engineer who created it. The BBU can transfer twice as much data to the video circuitry as compared to the Macintosh Plus, giving the SE a noticeable speed boost. But the truly fascinating part of Kai's post is a link to a super high-resolution microscope image of the BBU internals, allowing you to see even the individual logic gates clearly. Pretty incredible. In today's video, I'm going to install connectors, sockets, and ICs. Now, before I get started with the build, I just want to show you something here. Kai not only sent me that water-damaged motherboard, but he sent me the entire Macintosh SE that housed that motherboard. Yeah, as his expense, he shipped this over to me. Now, he did an amazing job, it seems like, cleaning off the rust that was on the metal frame and the power supply. Some of it's still visible in various places, but it's very clear that this was water damaged, and there was a lot of high humidity inside here for a long time to rust even the frame around the flyback transformer and so on. But I've been scared to flip the power on with the motherboard inside because I'm going to need some of the chips off of the motherboard, and I didn't want to have the magic smoke come out, you know, and damage those parts. But Kai encouraged me to show you what happens when I turn it on. So what I've done is I removed the motherboard and I checked the voltages at the main power connector where it connects to the motherboard, and I'm getting, you know, reasonable 12 volts, 5 volts, minus 11 volts, and so on, what you'd expect. So I feel more confident about trying it. I have the motherboard installed, the main connector is connected, I've got 4 megabytes of RAM, and the jumper is completely removed, which is set up for 4 megabytes of RAM. So let's see what happens when I switch on the power. And yes, I have the speaker connected too. 3, 2, okay, the fan comes on and we get a checkerboard pattern. Alright, I was imagining something far, far worse, but okay, alright, so you can sort of see a little bit of the broken up icon there. Very interesting. Well, that is what happens. Alright, as we get started with the build, it's important that we look at our bill of materials, BOM, or parts list, however you like to call it. This is based on Kai Robinson's BOM. The difference is I added more information for you. So the location of where each of the parts go, I added that, and I also added my own notes, what I personally had in inventory myself, parts that should work. And I also provide other information like if I had to buy it on eBay, is it available from a place like UT Source in China, the Exos Atari store in the United Kingdom. But most of the parts on my lists are from Mouser, and anything that says eBay or something else was not purchased from Mouser. And this document is available for you in the text description below. I've put a link for you there, and I will try my best to keep that updated over time. So there's no particular order that we need to install in. You can jump around if you like. You have the freedom to do that. But again, I would refer you to my part 1 video so you can install the resistors, capacitors, inductors, in other words, the passive components first. Those are small. It's going to make your life a lot easier to do that. And one of the things that I forgot is that, well, you know, diodes are passive components too. And I forgot CR1, CR2, and CR3 in my part 1 video, but that's okay. We're going to do that now. Now, I'm going to show you here on my board where CR1 is. I actually removed it from the stock board so I could read its part number. And the physical location on the board is here. And CR1 is just your run-of-the-mill silicon diode, 1N4001. Nothing special about it, so you could use 4001, 2, 3, 4, 5, 4007 if you want. They basically just differ by voltage, so the higher up the number you go, the higher the voltage spec. Nothing magical about it, except that it's rated for 1 amp. And so I looked in my stock and I have a 1N5399, which is basically the same diode, it's just 1.5 amp rated. The forward voltage drop is pretty much the same, almost identical specs. The body length is just a little bit longer than the stock diode, but it will fit just fine in the holes. And you just want to make sure that we get the ground stripe over here on the left side. And then there are 2 more diodes, CR2 and CR3, which are of a different type. The stock board shows they're 1N4148 switching diodes. These do not carry as much current. Sometimes if you buy, you'll see they can handle only 200 milliamps. The ones I have here can handle 300 milliamps. Basically, they're switching diodes. They don't carry a whole lot of current. We need 2 pieces of those. I had these in inventory. I purchased these from AliExpress some time ago. And one thing I should note is if you buy cheap components, whether it be resistors or whatever from AliExpress, they work. And they're not bad parts, but they go cheap on the wires. They're a little bit thinner than what you're going to get from Mouser. Now that's not really a big deal because 200, 300 milliamps, you know, these wires, the thickness of these wires is all you really need. But if you prefer the thicker wires, then you should buy these from Mouser instead of, you know, I mean, I would suggest you buy most of the parts from Mouser instead of AliExpress anyway. That way you know what you're going to get. But if you just notice that my wires are really thin, that's the reason why. CR2 and CR3 are located in this section of the board. So I'm going to install these 3 diodes now. So as I mentioned in my part 1 video, sometimes the solder will go through to the other side from the bottom to top as it did here on the left side of these diodes, but it didn't do that on the right side. You can leave it just as it is because it is making electrical contact, but if you want to be consistent and have everything look the same, then of course you would put a little bit of solder here on the top side too, and it just makes it look a little bit more consistent. Those 2 are finished. Next is the headphone jack. Note that with the headphone jack you'll get this little screw-on guy here with it, but that is not used on the SE30 motherboard. It would actually fit, but there's really no need for it, and if it gets loose and falls off on the inside on the motherboard, that could short out something, so there's no reason to use this. And here is the location of the headphone jack on the stock motherboard. Note that directly above it is this metal piece. This connects into the chassis. It's chassis ground. And so, of course, you have to install your connectors first because this goes above that. And I'm going to do this dead last because once I remove this, I also need to use some rust remover and see how that goes and then figure out a good coating to try to keep the rust from coming back. But that will be at the very end. Now, one thing I noticed, these 3 holes here are where the headphone jack is supposed to go. This topmost hole is slammed right against the edge of the board, so much so that just a very little bit of it has been sliced off. I don't know if that was deliberate or accidental or what, but if you look at the stock motherboard, the green one here, you can see that the topmost pad, there's a little bit of a gap between the edge and the top part of its circle there. So in other words, these 3 holes are pushed down more this way on the stock board, and on this reloaded board, these 3 are closer to the edge. And so what that means is you don't want the headphone jack piece sticking out too much. So to prevent it from sticking out, you're going to need to push it back as far as it'll go, this direction, this way. And even then, it sticks out just a hair more than the stock one, at least on my board. I don't think that's a problem though, but one other thing we're going to have to be careful about is if you push it all the way back, you should be fine. But if you push it out here, not only will it stick out more, but look, yeah, you don't want it to be at an angle, right? Because the plastic case is going to be right here too. So you want to make it as straight as possible. And that's another reason why we want to push it all the way back and then make sure it's straight when we solder it in. And I'm also going to use my thicker solder to make it a bit easier. So let that one cool to lock it in. And before I soldered it in, I had each of the corners propped up about the same height so that the headphone jack's top part would lay flat against the table. And that way all the feet would come in at the same length. The bottom of the body would lay flat against the top part of the board. And you can see how the bottom of the body is pressed nicely against the top of the circuit board. As to those long feet down on the bottom side, well, I might need to bend those. I will determine that at the very end when I put the motherboard in on whether I should try to bend them or just clip them off. Next are the J2 and J3 serial connectors. Now, because of all these pins on the bottom, we're not going to have as much flexibility, maybe none at all, to push this forward or back on the circuit board. I've got the first one inserted here, and it's just a hair past the edge of the board. And when I put these in, I must say that the fit is pretty tight, quite tight. So you don't have any ability to move it at all. You just have to go straight down into the hole. My camera is firing straight down, perpendicular to the board, and you can see it just barely sticks out, both of them, just a little bit beyond the edge of the board. The stock board connectors do that too, but just a little bit less, so maybe it's not a problem. We'll find out later. So to make it easier, I used thicker solder on all of these since they had big holes. Now I'm going to use my thinner solder here. This is actually 0.6 millimeters thin solder. Now, taking a closer look at my soldering job, I just want to mention that these two pair, or this pair, and this pair, and this pair have very little distance between them. So if you put too much solder, you could bridge them accidentally, and you're going to need a magnifying glass or a microscope to see it effectively, especially with all the flux around it. It's sometimes hard to see, but as you can see, even though my solder application wasn't 100% the same on all of them, even this one is not touching. So they're not shorting, and this is fine. Next is J4, the external SCSI connector. I purchased two so I could compare because they are a little bit different. This is an eBay purchase and this is UT Source. This is the eBay one. The first difference is it's a closed back. You cannot see the pins, or at least mostly you cannot see the pins. And this is the one I bought from UT Source. Again, in my parts list, you'll get a link to both of them. This is open back and you can see the pins a little bit more. And the other more significant difference is the one I bought from eBay has the bolts, and the one I bought from UT Source doesn't. So the bolts are used by some connectors if you want to screw them tightly onto the connector so your cable doesn't pull out. And this is the stock board, and you can see it has them on either side so you can screw in your cable if you like. Here is the Harding Technology connector purchased from UT Source. It fits in nicely and it sticks out beyond the edge about the same amount as the stock connector. And this is the one I purchased off eBay, and it sticks out about the same, so no problem going in, and all the pins fit fine. Plus you get the benefit of your bolt-on connectors. I mean, most of us probably won't use that, so really what this means is you can use either connector. It's just your personal preference and from what place you wish to buy. Since I like bolts, I'm going to go with the eBay version. You do not want to solder it in like this, because even if you put something flat under it to push it up, it doesn't have a flat top. So what I'm going to have to do is take it with my left hand finger. I got my middle finger under it, pushing upward to make sure it's flat against the board. And then I'm going to tack down the best I can some of these pins. It would probably help if I put flux on it, but alright, so that gives me a flat connector on the other side. Now that we're finished with external SCSI, we can go to J5, which is the internal SCSI connector. And they come in this nifty anti-moisture bag with a lot of silica gel, but sadly the part number that was on Kai's BOM 87831-5019, which is exactly what I ordered, is wrong. The pitch is wrong. This is too small. So I have two options. I'm either order the correct one or desolder the one off of the stock board and use that, but I don't want to do that because that's in the water damaged area. So I'm going to have to order it, wait, and that will go in last. I'm now going to do J6, the external floppy connector. These are very hard to come by, but thankfully Kai came to the rescue and kindly advised me to purchase from the Exos Atari store in the United Kingdom, and that's where I got it. I actually purchased two since I have more than one board, and it's a perfect fit part, so I'm going to solder it in now. Okay, next I'm going to install J7 and J8, which is over here. And these are the upper and lower internal floppy drive connectors. I just purchased these off Amazon. They're just cheap old things, no gold-plated pins or anything like that. But in this document I put a link where you can find these on Amazon USA. These are harder to install, so I'm going to add some flux here. Well, some of the pins on this upper one are sticking up more now, so that's not good. Obviously, I should put in the actual cable. That might help, and use less heat. Well, I don't think I can fix the pin, so I'm going to remove it and use another one and try again. Alright, we'll apply some flux and hopefully my hot air station will be able to desolder him. And I put this metal piece here so I wouldn't accidentally desolder the connector behind it. Well, I was able to pull it out, although one of the pins is still stuck in there. Got the hot air station set to 400 degrees since 360 wasn't doing it. Maybe putting solder on it will help get him out. Okay. Clearing the holes is no fun at all, so I'm going to use my little desoldering tools here. The smallest tubular one will fit. And go through one at a time. I did this one already. And this one, okay. Very tedious job. I cleaned out all of the holes very well. Still, there's a little bit of residual solder lining the holes, so it's made them a little bit more narrow. But again, that's a good thing because it's now holding it firmly flat against the top of the board, and I can just proceed with my soldering, although I'm going to do it at a slower pace now so as not to melt the connector and cause the pins to fall through the holes. Well, that was annoying and ate up a huge amount of time, but we're finished and can move on to the ADB connectors. Now, I tried my best to try to fit it in there with these curvy legs, but it just won't work, at least not for me. So, what I had to do is to take a pair of pliers and then you're going to straighten them. You don't have to straighten them perfectly, but straighter than they are now. Squeeze it. And they're still a little curvy, but this will allow them to fit into the holes. And that's important because you don't want to accidentally bend these or otherwise mar your connector. And with those straightened legs, it easily drops right in. And on the flip side, I'm going to make sure that it's not coming out past the edge of the board. So I'm pushing it this way, but also my finger, index finger on the other side, is pushing up on it, making sure it's flat. Push out. That'll help hold it in there, but I'm actually going to have to hold it or put something underneath it while I apply solder to these. Alright, I've got it laying flat on my table. So, and we'll take my thick solder. Much easier to solder in than those floppy connectors, that's for sure. I think this might be tinned and the floppy's not. Okay, and then I'll do the smaller ones here. They both stick out just a hair past the board, but it can't be helped because I wasn't able to push them in any more than that, but they should be fine. We'll find out later. And ta-da! Our backside edge connectors are complete. Got that finished. I'm going to skip J11 for now. I'll explain later why. Then we have J12, 13, and 14, and we've got the main connector. It sticks up quite a bit. So does the PDS connector, and then we have SIMM Sockets, which also stick up a lot, and Kai told me not to install the SIMM Sockets until last, and I assume that's because they stick up so much and it's going to get in the way. So I'm going to skip J12 through J15 because of that. The next one is PRAM battery. I'm going to use the stock holder. You can be purchased from Mauser, by the way, and that sticks up a lot too. Now, some of you say, hey, why not a CR2032? Well, if you want, you can install that, but just keep in mind that those batteries will last not nearly as long as the stock battery half AA would. So I like battery life, and I'm willing to take the risk. You know, I'm not going to forget and leave it in there. If you forget and leave it in there, it's going to be bad. That's the benefit of the CR2032. It's not going to explode and leak. So I'm not going to do this either yet, and that leads us to IC sockets. And I just happen to have a kit that I purchased, and this is from Amazon Japan, so I assume you can get something similar from Amazon USA. This is very nice because you've got multiple, it says 10 values here, 40 pins, 32, 28, 24. You get 4 pieces of each of those, and then 20 pins, 18, 16, 14, 8 pins, 6 pins, and you get more pieces of these. So it's a very comprehensive kit that contains pretty much everything except for the 68,000. And if I open it up for you here, it's got the same piece of paper, you know, in the top that tells you what is what. And basically you can just pick out the sockets that you need. These sockets are very low cost, but they are the double wipe kind. And that means the IC pin will go down into in between these two pieces of metal. There's a piece of metal here on the bottom and on the top, and so it makes contact on either side of each pin. That's double wipe. Now these sockets are very low cost, so unlike some of the sockets you may have seen, there's no little plastic bars in the middle, and sometimes you'll see those plastic bars because they make the socket more rigid and durable overall, but as long as we're careful during soldering, it should be fine. I checked for sockets on Mauser and they have some very high quality ones, but they're also very high priced. I mean, too expensive actually. So I'm not going to pay, you know, like $2 or $3 each or $1.50 each socket, but if you are willing to do that, you can from Mauser. So I would recommend this kit. It's just much more convenient to use. Here's how the pins look on the bottom. So I'm going to start with U1C, and that's for the sound chip. And in my notes, I mentioned you want to socket this, and here's what you need, a 16-pin socket. So that'll make it very convenient for you if you follow this. But I also made mention of chips that you don't want to socket. This is per what Kai told me. He said there are some chips you just don't need to socket. And I marked those. And it says don't socket these, like the Bourns filters and so on. And so what I'm going to do is, unless I have a problem and need to comment, I'm basically just going to go down one at a time for all of the ones that say socket, skipping the ones that say don't socket. And I'm going to just do them one after another, accelerate the video so that this will not take forever, and then when done, I'll show you how it looks. I should actually take time to mention one important thing. For all the sockets, Kai has nicely marked this little part here. You don't see it on the other side, right? And that is supposed to be where this little indentation goes. You'll note on the other side of the chip it's perfectly flat, so you want to make sure that the indentation side of your socket is oriented just above this, and then you'll be fine. Now electrically speaking, even if you accidentally flip it and do the naughty thing of putting the indentation on the other side, so long as you orient the chip properly, in other words, the chip little indentation should be over here, it will still work fine electrically. So no problem. But it's going to be very confusing for you if you put in the socket wrong, so I'm just telling you now, don't put in the sockets wrong. Make sure you give due attention to that little marking there. And the last thing I will say is that even though these pin holders are not straight through pins like the internal floppy connectors, there's going to be less likelihood that one of them is going to pop out because you applied too much solder and melted the plastic. I mean, if you just keep the heat on for like 10 seconds or something, you could do that, but it's going to be safer. Even so, these are cheap connectors, and I'm not sure how the plastic's going to handle all that heat, so to be on the safe side, we're going to solder in one pin over here, and then do the opposite side, far away. And then do one over here, and then one over here, and then in the middle, and like that. We're going to jump around, and I'm going to go kind of slow. Even though I'm going to speed up the video for you, still I'm going to actually go slow to make sure the socket is not becoming too hot and I'm not melting plastic everywhere. Okay, now we can proceed. I'm now going to solder in this 64-pin socket. This is for U7E, the 68000 processor. Kai very kindly sent this to me. This socket is kind of special because it includes this Kapton tape at the bottom, which helps to prevent melting a little bit. It's found from a variety of sources. Mouser, I put links for you to Mouser, to eBay, to the Exos Atari store in the UK, but I could only find the Kapton tape version on eBay. So you can check that out, but even if you don't have the Kapton tape, I mean none of the other sockets do, it should be fine, but this is just a very high quality socket. And it does not have a notch in the middle, it has a little cutout up here in the upper left. Next, I'm going to do the BBU socket, which is marked in the middle U4E. It's important to note that even though all four corners of this socket are rounded, one of the corners is flattened off. And as you can see, the white silkscreen marking, it's this bottom right corner that we need to match up that and then put in our socket. I should mention that this is the stock motherboard here. You will need to pry out the chip from the stock socket. If you don't want to buy one of these sockets from Mouser, then it's going to be a little bit challenging, but if you have a hot air station, you might be able to get this out without damaging it. But to make sure you're going to get a perfect socket, buying one is always the case. Now, getting this chip out, I thought that buying one of these chip extractors would work. And, well, it somewhat fits in there, but not down all the way. And so I actually ended up scratching the chip and wasn't able to get it out with that. So I ended up going with, I have a little probe that's really not made for this, but it's got a metal tip, and I was able to pry at both ends. There's a little hole here and here where you can pry up, and I was able to get the chip out using a very non-standard way of doing it. So you're going to need a piece of metal. You're not going to be able to use a toothpick, but something toothpick shaped but strong metal, and you should be able to pry up that chip. And then once we get the board and start putting all the sockets in, then I can put the chip into the socket. Next, I'm going to do the Bourns filters at U2B, U4B, U8B, and U11B, which is here, 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 and here. And these chips, as is true of any chips really that are brand new, the legs don't point straight down, they stick out a little bit. So if you try to put them in the sockets in that condition, then it won't work. So you have to bend the pins a little bit. What I do is I just put the chip on its side and rock it. It has to be on a flat surface, of course. And do the other side and just kind of turn it inward. And that helps to straighten it out. Woohoo! It drops right in. Next we'll do U11A, the ADB filter, also known as the halo filter. And we want to make sure that pin 1, signified by the dot, is matching up with that square pad. Next we're going to do U2E and U2F. And I straightened the pins, which makes it go in really nice. Next is U11F and U12F. Next, I'm going to solder in U10D, which is the 15.6672 megahertz crystal. Kai very kindly sent this to me. This is a 4-pin dip style crystal, and the key to connecting it correctly is you'll notice that 3 of the corners are rounded, and this one here is rounded too, but not really so much. It's more squared off, and that squared off side is where the dot is located, and there is no dot on here, and there's no plus, out, or ground markings on here. But basically you need to look at the white outline, because if you look at the white outline, these 3 corners are rounded, and then this corner at the bottom right is squared off, and here's the squared off. So basically pin 1 goes to the bottom right, the squared off portion. Next is the main power connector at J12, and the key to putting this in correctly is you'll notice there's a little notch on one side, and on the silk screen you'll notice that the notch is opposite the J12 marking, so we want to make sure that our notch is lined up in the correct orientation, like that. Now this connector is as tall as the ADB connectors, so on this side of the board, the ADBs lay flat against the desk, this lays flat, and then on this side of the board over here, I've propped it up to be the same level, so I don't have to do any tricks now to tack it down like you've seen me do on all the other components. I can just take my solder, and this is the thick solder, by the way, because there's a lot of area that I need to solder down, and I can just solder it in. Of course, we don't want to melt the connector, so I'm going to do the opposite side. And come over here. We'll get it, maybe one over here in the middle. Now it's time for the PRAM battery holder. I like things to be stock, and I like battery life, so I'm not going to do this CR2032 like so many people do. But you can do that if you'd like. And both of these parts come from Mauser. This is the little top piece that locks the battery down, so it's not going to pop out. It's not going to pop out by accident anyway, but this is just the piece if you want it. It's a separate part. And on the inside of this holder, it shows plus side is this way, and then of course the silkscreen marking. We basically just need to match up the leads like so. It comes quite close to this capacitor, but there's still a gap in there. It fits just right. It fits in there fairly tightly, so I didn't have to do any funky things to get it in there, and I just propped up the board to an equal level. It's laying flat against my desk, and now I'm just going to use my thick solder to solder both sides in. Now it's time to install the SIMM sockets. This is for your memory, for those of you who don't know. These are very nice, they're keyed, they only go in one way. Extremely high quality. Kai very kindly sent these to me, and they have metal tabs. Don't you just love the metal tabs, folks? I mean, for those of you who have an SC30 or another board that have the plastic tabs, they break off. They break off. But metal, oh, this is the socket of dreams. So we're going to install that now. Now it's time for the J13 PDS connector. The key to orienting it properly is in the silk screen. You'll notice this line over here on the left. That's dented in towards the connector more, and then this bottom part here shoots out to the left, and it's the same on the opposite side. So in other words, the fat parts of it need to come down towards the edge of the board, and that is the orientation that you see here. So these little tick marks are the part that juts out, right, on the top. And also, if you look here, this part is fatter than this, and same on the opposite side, fat and thin. So you do not want to put it in the other way. It will fit, but this is incorrect because you can see here, this part juts out, right? Doesn't match the silk screen. So the key is just match it with a silk screen, and then of course put it in the right holes so that the edge of the connector is just right up against the line. Well, sadly I found a showstopper. The connector will not sit flush with the board. It hovers 2 millimeters above the board on its legs. The problem is that the holes are 1 millimeter wide, but the base of each pin measures about 1.16, just under 1.2 millimeters, and there's no way to make that fit. So I'm now going to have to figure out what the compatible part number is for these 1 millimeter wide holes. And that's 1 millimeter wide with my calipers really stretching it. It often measures 0.99 millimeters. So the pins need to be just under a millimeter for them to work. Probably the gold plating is making it less than a millimeter, 0.99 millimeters in some cases. Anyway, I just ordered a Mauser order, and I got enough in the order to qualify for free shipping, and I don't really want to pay $20 for shipping plus the cost of these expensive connectors. I could desolder one on the board, but that board, I don't know. This is probably the most painful one to desolder, and I'm afraid that I'm going to probably melt the plastic in the process. I don't know. Anyway, that is going to bring an end to this part 2 video. Well, I lost a little bit of hair in the process, but overall, this part 2 build wasn't too bad. And yeah, the internal floppy connector cost me 40 minutes of time, but we don't hide mistakes in these videos. We show you the mistakes so that you don't have to make them. And I was able to work through that. And yes, the PDS connector, I've already ordered replacements. Kai jumped to the quick rescue and gave me the correct part number, the pins that are thin enough to fit into these 1 millimeter holes. So my part 3 video will show you the PDS connector soldering it in, and also I'm going to show you how to desolder certain components that will be needed for use, for example, these 2 coils, and also the metal bar will also be needed to be moved to the SE reloaded board. And once I remove this is going to be a challenge because it's one huge heat sink. I'm then going to use some rust remover to remove the rust. I've got steel wool to remove any residual rust that the rust remover doesn't remove. And then I got to figure out a way to prevent the rust from coming back, but yet in a way that will be electrically conductive and also solderable, because I'm going to need to be able to solder it back in, and the heat from the soldering iron should not damage whatever protection that I put on it. So I'm still thinking about that, and that is going to come in my part 3 video. Now, as I mentioned in my part 1 video, MacEffects sells the glossy red version with golden egg pads, and they have approached me to say they're willing to give you 10% off. That's right, 10% off when you buy an SE Reloaded board, or if you buy Kai Robinson's Mac Classic Reloaded board. So you could buy only the SE Reloaded, only the Classic, or both, and you'll get 10% off of your purchase of those boards when you use the magic code JDW at checkout. Now, JDW is all capital letters. And I do not receive any kind of commissions or kickbacks whatsoever. MacEffects will send 100% of the proceeds of your purchase to the well-deserving creator, Kai Robinson. So not only do you get a great board when you purchase, but you'll also be supporting the man who made it. And I know what you're thinking. You're saying, well, glossy red with golden egg pads, it's really nice, but I want a glossy blue, right? Or some others of you may say, well, the glossy blue and glossy red are nice, but I want the matte black with golden egg pads. How can I get these? And it's a good question, and the answer is that Kai Robinson has in his inventory in the UK stock of the blue. So he said that he is willing to ship within the UK and to many parts of Europe. He didn't say outside that area, so I don't know. What you should do is, in the text description below, I put a link to the Tinker Different forum, and that's where you can contact him. You can just send him a private message and see if he'll ship to you if you want the blue board. Now, for the people out there who want this matte black, well, Kai said that once he sells through his inventory of the blues, he would consider buying inventory of the blacks. But he doesn't want to buy both because he doesn't want to end up with dead stock that he's not able to move, because he buys them 30 pieces at a time. Now, what if you want to make it yourself? That's probably another question you're going to ask. You technically can, because on Kai Robinson's GitHub, he makes the Gerbers available for you. So you could send it to PCBWay, to JLC PCB, or another PCB maker of your choice. But the problem is that for PCBWay, JLC PCB, and most of the other PCB makers in China that I've seen, they require a minimum 5-piece order. So Kai Robinson's licensing terms don't allow you to resell this. You would have to retain them for personal use. And I don't know about you, but I don't think I need 5, right? And probably you don't either, but that would be the requirement if you were to make it yourself. Now, if any of you know how to order up the boards one piece only at a time, if you know of a PCB maker like that, then please let us know down in the comments, because that would be useful information, because I've not found a PCB maker like that. They all have a minimum order of at least 5. And it can be costly to make these boards, especially if you get the gold Enig pads, because they charge extra for that. And the matte black color, at least at PCBWay, they charge extra for that as well. So that is how you could technically make it yourself. And next, I'd like to very humbly thank 8 extremely incredible people who generously contributed to this YouTube channel by PayPal over the past month since my last video. I'd like to start off thanking Philippe from France. You probably know that name if you watched my last video, because Philippe had made a donation at that time. Well, he made a second donation. So I wish to say a true heart of thanks to you, Philippe, for liking my content so much that you made a double donation. Thanks a lot. Next, I'd like to thank Gavin Maxwell from Australia. I'd like to actually give him a double thanks as well. Thank you, Gavin, because he made a double donation. He watched some of my videos and felt he was benefited by them and just wanted to donate more than once, and I appreciate it very much, Gavin. Thanks a lot. Next, I'd like to thank Mark Jozaitis from the USA. Thank you, Mark, for your donation. Next, I'd like to thank Victor Norgren from Sweden. Thank you very much, Victor. Next, I'd like to thank Mauro Acciaccaferri, the name all of you know if you watch my videos, because he is a monthly PayPal supporter of this channel, and I truly mean mean it from the heart, Mauro, when I give you my thanks, because it truly means a lot to me that you value my YouTube channel content that much that you wish to continue supporting me on a month-by-month basis. Next, I'd like to thank Mr. Fahrenheit. Now, Mr. Fahrenheit, if you don't already know, was the gentleman who started up a new forum, which we now call Tinker Different. He did not come up with the name himself, but he assembled all of the people who were founders of that new forum, myself included. I was one of the founders, and he helped put that together. I don't know if we'd have a Tinker Different today if it wasn't him coming and bringing all the people together who created it. So he is the founder of that forum, but also he is the creator of Mr. Fahrenheit 60 nanosecond VRAM. And this is useful if you have an overclocked 68040 Mac, if you overclock with K-Koba's Spicio clock, for example, the LC575, which is used in the Color Classic, known as the Mystic, or an LC475. You can see my videos about all the details on that. He did not give a donation so that I would advertise what he sells, but I'm just happy to plug it because I know that he has a lot of these VRAM modules. He purchased a lot of chips and he makes them by hand, but he does an amazingly good job. So I put a link for you in the text description below if you'd like to go to the Tinker Different, and he has a product page over there at the Tinker Different forum that you can check out. And again, you'll need a Spicio clock. Now, of course, K-Koba has his own RAM too, and Drake sells his own RAM, but I just wanted to mention that Mr. Fahrenheit does an amazingly good job on his VRAM, and even though you could use it on any machine, even an unclocked machine, the benefit over the stock 80 nanosecond speed VRAM is overclocking. So you can overclock much, much higher when you have fast 60 nanosecond VRAM. So I just wanted to say a big word of thanks to Mr. Fahrenheit, not only for creating the helping kickstart the Tinker Different forum, but also bringing this VRAM to market for us. Next, I'd like to thank Alexandre. Now, I'm not saying his full name because I didn't get permission, and I didn't get permission because of PayPal. PayPal hides the email addresses now of most people. I'm not sure if it's allowing you to hide them. If it is, that's fine. I respect your privacy, but the problem is that PayPal doesn't send you any notifications at all whenever I reply. In fact, if you log into PayPal, it doesn't even send you a notification then. It's crazy. And so when I sent Alexandre, 3 messages in reply, but he didn't see them. And so if you ever send a donation, I have a PayPal link in the text description below. If you tell me, yes, you have permission to use my full name and thanks, then you don't need to worry if I email you or not, or try to contact you or not, because I have the answer. But if you just send a donation, then if I don't have your email address, I'm going to try to contact you by PayPal messaging. And you're just going to have to open up PayPal and then go to your original message and dig down, and then you're going to see a message from me. I usually reply within a matter of hours from when I receive a notification of a PayPal donation. So I just wanted to mention that, not to complain, but just to let you know how PayPal works. It's kind of broken with regards to its messaging. Next, I'd like to thank Marcus Hesse. Now, Marcus did not send a PayPal donation. He sent something perhaps even better. He sent this, which is an entire Macintosh SE motherboard, which has, as you can see, this looks a little different, right? It has a 16 megahertz, 68,000 CPU Levco Supermax speed card accelerator. Ha, that's a mouthful. And I've tested it and it works fine. He sent me a photo prior to sending this off to me, and these 2 chips, which have the glossy black tape on them, did not have the tape originally. There were stickers on these 2 ROM chips, and that was scratched away. And underneath the stickers was the little circular windows there, which you can erase them with sufficient exposure to UV. So he had no means to test it and didn't know if it would even work, but he mailed it to me. So not only did he contribute the value of this SE motherboard, but also the value of this somewhat rare to find card, and he also paid for the shipping as well. So he really made a serious donation, and I appreciate it very much. And like I said, I did confirm that it works. So when I finish my SE Reloaded build, I'm going to show you the testing of that motherboard, and at the same time I'll also show you a little bit more about this as well. Now, Marcus was telling me that he works for an IT firm in North Carolina by the name of Black Glove, and what caught my interest though was that he said it was founded by former Apple engineers. So the business specializes in consulting and distributing and managing Apple computers mainly to businesses and to K through 12 schools. So not only do you get to work with the former Apple engineers who created the company, but you get to work with Apple computers most of the day too. And I thought, wow, that must be a fun place to work. So he didn't make this donation for me to plug his company, but I just wanted to say I thought it was a bit interesting. So I guess if you're in the North Carolina area and you need some help and you're a business or a school, you can look up Black Glove. Separately from that, I would like to thank a gentleman by the name of Mike Morgano, who sold me this somewhat unique vintage Mac goodie. And you might say, what, you're giving thanks to a seller? And yes, I am. I'm thanking him because he could have just as well sold this to someone else who probably would not have made a video for you to see what it's all about. And this is actually an Apple IIe card. And not only did it come with a card, but it also came with the coveted Y cable, and he also sent the required software on disk, and he also sold me the manual too. So again, this is an Apple IIe card that will transform compatible vintage Macs into an Apple IIe. Pretty neat. And what I'm going to do is make a dedicated video about this eventually. This had leaky capacitors. It was really a mess. It leaked all over the place, but he used alcohol to clean it up. And I haven't tested it yet, but I haven't seen any damage. But what I'm going to do is I'm going to do a video of the recapping of this board and the cleanup, and then I'm going to do testing. So I just wanted to show you this to thank Mike, but also to say that I've got more great videos coming, folks. So you need to stay tuned for those. And Mike, yes, I'm definitely going to be doing a video on that. It just needs to come after my SE Reloaded series is finished. And I should also mention that in past videos this year, I've mentioned a family medical emergency, and that is still ongoing. And the reason why is, I'm not going to give you all the details, but basically there's cancer in my immediate family. And treatment lasts a half of a year, and it consumes a lot of my time, so that's why I have less time to film and edit. And that's just an ongoing thing. So I just wanted to mention that, just so that everyone would know that has not been resolved yet, and it is still very much ongoing. Next, I would just like to say that if you like this video, please consider giving it a thumbs up. Please also subscribe if you'd like to see more content like this, and be sure to let me know down in the comments if my SE Reloaded Part 1 and this Part 2 video has inspired you in any way to give the build a try yourself. Now, I will agree. If you go on eBay, you go on Craigslist and other places, you could probably find an SE board for a much cheaper price than it's going to cost you to buy this reloaded board and all of the components, assuming you want to buy most of the components new like I am doing. Yeah, you could get it cheaper that way. I'm sure you can. But as I said before, the best way to think about SE Reloaded is you're building a Mac. Okay, you're not building the CRT, you're not building the analog power supply, part, but you're building the heart and soul of a vintage Mac. At least that's the way I like to look at it. And it's just, it takes time. I agree. You need soldering skills. I agree, but you have my videos, right, to help you now. And I'm finding out, all of the bugs and the BOM and all of that so that you won't have to experience that. And you can just have the pleasure of building a vintage Mac board. And it's not surface mount, it's all through hole, and I think that's a lot easier than surface mount, which means the components are bigger, and if you have fairly decent eyes, you could probably do it without a magnifying glass. So I would suggest if you're interested in a project this is a fun project to consider. Just want to mention that. Thank you for watching today, folks. I really appreciate your time today. Don't worry, part 3 is coming soon. Take care.